All right. Good evening or good morning, good afternoon, whatever time you're watching this educational video. We will be dealing tonight or whatever time about vector analysis. And I have one problem here in which we need to find the resultant vector and the heading angle. So our problem, a ball rolls 9 meters east and then rolls 7 meters south due to strange and random wind. And figure out these are the tasks that we need to do at this very moment. Figure out the resultant vector and the heading angle. Yeah, heading angle. So how are we going to get the resultant vector? Remember, when we say resultant vector, it's just the hypotenuse of our right triangle. Okay? Or in other reference, they call it vector sum. And in this case, we need to know the magnitude of the resultant vector, meaning the positive root or the positive value. Okay? And we also have another task here to find the heading angle or our theta. We will be incorporating our saw, ka, toa trig functions here in order for us to solve or to figure out the sides of the right triangle as well as in determining the angle with respect to the direction. Okay, so this time we will try to draw what's going on here in our problem. All right, so in this case, the ball rolls 9 meters east. Let's say this is 9 meters, and then of course it's east. And then if you are going to add another vector or arrow, you need to just continue it by putting putting the tail of that new vector in your previous vector, if you know what I mean. So this is our first vector, 9 meters east, and then going south, you will just connect the tip of that new vector to the head of that previous vector. Say, for example, it's like this, 7 meters south. Now let's try to get the resultant vector, or we call it vector sum or hypotenuse. Okay, so that is where the starting point, you have to connect the line from the starting point all the way to the ending point. So this red line here is going to be our resultant vector. We will be using the symbol, let's say V, with an arrow above to represent a vector, and we need to have the absolute value of it or the magnitude of that resultant vector. So in order for us to get the value of our resultant vector, we need to use our Pythagorean theorem. We need to apply this one in our formula. Resultant vector, the magnitude of it is just the square root of a squared plus b squared. And always remember, you can assign any of the sides to be the A side or the B side. Let's say this is going to be your A side and this is going to be your B side, or this will be your B side or this is going to be your A side. We will still have the same answer because we were just adding the sides, right? The squared of each sides. Let's say, for example, we agree or you chose that 9 will gonna be the A and then 7 will gonna be the B side. So very easy. All you have to do is to continue this one. A is gonna be the 9 meters. Don't forget to square it out. And B is gonna be the be 7 meters. So 7 meters and then squared. Squared sometimes due to limited time, we mistakenly, do the math. So doing instead of doing 9 times 9, that's 9 squared. Or yeah, instead of doing that, we tend to do 9 times 2. So it's gonna be the wrong interpretation. We need to multiply. When we say 9 squared, we need to multiply 9 by itself. Okay, so we will do it here. 9 times 9, that's gonna be 81. And remember, you have your unit here, meter times meter. You will have meter squared. That's still square root. Plus 7 times 7, that's gonna be 49. Meters times meters, meter squared. Then let's continue. Let's add, because these two terms have the same units, meter squared, so we can simply add these terms directly. So 81 plus 49, the answer is 130 meters squared. And to get the square root, cancel the radical sign and cancel this squared here. So you will have a remaining 1 meter unit, and get the square root of 30 and make it in a decimal number. So you can have 11.4. Do not forget the unit. And remember, we're talking about the magnitude of the resultant vector. So always provide the positive or the absolute value of your answer. Okay? Always positive, because we need to find the resultant vector. Okay, we're not yet done. We need to solve for the heading angle. Okay? As agreed during our discussion, we need to have our first vector as our reference direction. So in our case, it started with 9 meters east. So in this case, we will be using this measurement of the theta, or the angle here. This is the starting position. All right, so we need to use that location to measure the angle from east going to south. Okay, and in order for us to determine the theta, please recall that in our right triangle, we have the hypotenuse as our resultant vector. This is our hypotenuse. And again and again, your resultant vector will always be the hypotenuse of the right triangle. And of course, we have our desired theta here with respect to the first direction, which is 9 meters east, going east. So automatic that this side fronting our desired angle to measure, it will automatically be our opposite side. And the side where it is adjacent to the angle to be measured, we call it also the adjacent side. Again, if this is where our angle, automatic that this side will gonna be the opposite. And the side of the triangle where the angle touch it, or the angle touches it, that's the adjacent uh, side of the triangle. Okay, so in order for us to find out the theta, or the angle, this is a trig functions that we need to follow. Okay, this is how are you going to convert it into equation. T, letter T stands for tan theta, equals O is for opposite, then you will divide it by A. This is TOA. Okay? So A is adjacent. This is your opposite side. This is your adjacent side. Okay? Let's continue. We'll write again the equation. Tan theta is equal to opposite over the adjacent. Okay? In this case, we need to get the theta. This one. And in order for us to isolate that theta symbol, all we need to do is to cancel tan or the tangent. So we will be dividing both equation by tangent. So we can cancel tan, and then we can have the theta as the desired unknown that we need to calculate. And then remember, opposite over adjacent, and then we need to divide it by tan. In dividing fractions, you multiply it by this one. But remember, it is understood that it has a value of 1 there. Tan over 1. So in dividing fractions, we need to have the reciprocal of this. So tan over 1, that's going to be 1 over tan. So we need to do some cleaning of our equation here so we can finalize it as opposite times the adjacent. Then we can write this as tan raised to negative 1 or inverse tan. So that's why we have this final formula to get the angle of our right triangle. In using your scientific calculator, all you have to do is to press shift, then press tan. In your scientific calculator, again, shift, tan, and then you have to input there the value of the opposite and then the value of the adjacent, then equals to get the answer. In our situation earlier, we have 9 meters going east and then 7 meters going south. And we need to find the resultant vector. How to find the resultant vector? Just use the Pythagorean theorem. Okay. Next is we need to find the heading theta or the heading angle. By doing so, all you have to do is to follow this formula. Input it in your calculator. Just press shift plus tan. Then you will see this prompt on your calculator, tan raised to negative 1. After you press shift plus tan, it will appear. And then continue by looking at the opposite side of the right triangle and the adjacent side. In this case, it's going to be our angle. This is the opposite and this is the adjacent. So our formula is opposite over adjacent. Let's continue. So again, press shift and then press shift and then tan in your scientific calculator. The opposite side is 7 meters and then the adjacent side is 9 meters. This time we can cancel the unit meters. So in doing that, shift tan, then 7 divided by 9 and press equal, you can have this answer. 37.87. And don't forget, since we're dealing with angles, we need to have degrees. Before I will forget, set your cycle into degree mode before you will be doing this calculation. All right. And now our angle here is 37.87 degrees. And if we need to know the directions of our vector, resultant vector, this one, okay, we need to put some direction here. If you notice, this is from east going to south. So in this case, from east, it will measure 37.87 degrees and then going south. Okay? Or 37.87 degrees south of east. So that's it for this video. If it helps you at some point, if it helps you at some point, you can, yeah, support this by subscribing, sharing, or commenting. And if you have question, you can comment on the comment box below. Thank you and see you around until next time. Bye for now.